Good day everyone, I'm PAMELA ITURRALDE and my group mates are KATHLYN, BENDAña and RHEIN, NICOLE, PUNZALAN. We are the group 1 and we're here to present our oral report for experiment 1 called Buffer in Action. This presentation consists of the objective, overview of the experiment, methodology, discussion of the results, the conclusion, and the recommendations that will be discussed later on. And for the next slide, may I call Ms. Bendaña to discuss the objectives.
Thank you, Ms. ITURRALDE. So for the objectives, throughout the experiment, it was expected first to identify which of the 3 buffer samples is the best buffer. Second is to know the role and the importance of buffers in the human body. And lastly is to understand the effect of increasing or decreasing the pH of our blood. So overall, the significance of this experiment is basically for us to determine the best buffer used among the materials and also to understand how a buffer resists changes in pH upon the addition of acid or base solutions and how a buffer uses in a real-life situation. And through this, we will gather a new knowledge. So for the introduction, here comes Ms. ITURRALDE.
As you can see in the slide, the picture indicates the buffering. And when we say buffer, it is anonymous to the word stay, which is, we all know, very important to us. Let's find out more about it. Buffer is a solution that can resist pH change upon the addition of the acidic or basic component. Buffer solution contain high concentration of weak acid and its conjugate base and weak base and its conjugate acid, because these components can neutralize hydroperoxide ion and hydrogen, and buffers are highly resistant to pH change. It also keeps the pH of the solution constant. As I've said earlier, small addition of acid or base can neutralize it. Buffer works by neutralizing any added acid or base to maintain the moderate pH, making them a weaker acid or base. So now we can continue with the 2 types of buffer solution. The first one is the acidic solution. It is commonly made from a weak acid and one of its salt, often a sodium salt. Example of it would be a mixture of ethanoic acid and sodium ethanoate in solution. Also, acidic solution don't have a pH higher than 7. The second type is the alkaline solution. It is made from weak base and one of its salts. A frequent example of it would be a mixture of ammonia solution and ammonium chloride solution. An alkaline buffer solution has a pH greater than 7. For the next slide, it is the Henderson-Hasselbalch equation. It is used to determine a buffer's pH. It is an approximate equation that shows the relationship between the pH solution and the ratio of the concentration of dissociated chemical species. It includes the equilibrium concentration of an acid and its conjugate base pair used to create the buffer solution. And we can also note that all the buffers have a limit to their buffering capacity. For the next slide, let me call Ms. RHEIN to discuss the methodology.
The materials used are the dry milk, tang powder, Gatorade, lemon juice, baking soda, small glasses, medicine droppers, and plastic spoons. Yung dry milk, tang powder, and the Gatorade, yun yung buffer. Then yung sodium bicarbonate or the baking soda na ginamit sa experiment is yun yung nag-act as buffering agent. Then, it is a naturally occurring buffer that is a component of your body's acid-base balance, which preserves appropriate pH levels. When baking soda is combined with an acid, it becomes active. In our experiment, we combined baking soda with an acidic element, yun yung lemon juice, para maging active, para ma-activate siya. Then, in the experiment, first we added 20 ml of lemon juice to each of the 3 glasses. Then, we placed a 1 teaspoon of dry milk sa unang baso. then 1 teaspoon of tongue powder sa pangalawang baso, then 1 teaspoon of Gatorade sa pangatlong baso. In order to completely dissolve the substance in the lemon juice, hinalo namin siya for about 10 seconds. And after that, we set a 1 teaspoon of baking soda sa bawat baso at the same time, and we observe what would happen next. In the end, the best buffer that we observed was the Gatorade, because after 33.67 seconds, it stops.
Moving on, let's discuss about the discussion and result. So for the tongue powder, the time that shows the result is 1 minute and 34 seconds, and it produced the least amount of bubbles. When 1 teaspoon of baking soda is added, the tongue powder and 20 ml of lemon juice react gradually, but it still creates bubbles gently, going up when time passes by. Next is the dry milk. The reaction result shows 50 seconds, and it produced more bubbles compared to tongue powder, but less bubbles compared to the Gatorade. It actually did not instantly react when the baking soda was added. Lastly, for the Gatorade, it quickly reacted after putting a 1 teaspoon of baking soda. More bubbles are produced here that results in a thick foam. Since the glasses are too small, the bubbles overflow, and after 33.67 seconds, the reaction stops. So, to understand it more, let's answer the guided question. So first, we want to identify the 3 buffers used in the experiment. So in this experiment, the 3 kinds of buffers that were used to resist the change in pH of other present solutions are dry milk, tongue powder, and Gatorade. Next, which of the 3 buffers is the best buffer? So according to the data that we gathered, the best one out of the 3 buffers is the Gatorade, since it has the shortest reaction time, which is 33.67 seconds, making it efficient. So additionally, it was discussed that it is neutralized more by the added acid, which is the lemon juice. So the reaction for the baking soda, which is the base component, will be much more less. As we look back, Gatorade reacts to the lemon juice, so the Gatorade solution will be called a buffer solution with added acid. While Gatorade is regarded as the finest buffer, there are many base components that can be neutralized by the added acid, meaning few will react with the baking soda. In addition, it was mentioned that buffer must be highly soluble in water and minimally soluble in organic solvents in order to remain in the biological system aqueous medium. So, in other words, since Gatorade yung best buffer, it means that marami nang na-neutralize sa added acid, which is yung lemon juice. So, konti na lang yung magre-react sa baking soda. Because once na mag-react yung buffer sa acid, may buffering na nagaganap and man-neutralize yung reaction doon. Tapos yung matitira na hindi na-neutralize ng lemon juice sa Gatorade ay ang magre-react sa baking soda. So, another clue to know the best buffer is kung ano yung shortest time. So for number 3, what is the concentration of the substance used in the buffer solution? So based on the experiment, the concentration of the substances used in the buffer solution are 1 teaspoon of dry milk per 20 ml of lemon juice, then 1 teaspoon of tongue powder per 20 ml of lemon juice also, then 1 teaspoon of Gatorade per 20 ml of lemon juice. So the amount of solute in a certain amount of a solution is how concentrated a material is. Next, how is the strength of the buffer determined or measured in the experiment? So the strength of the buffer is determined through the volume and concentration of the dry milk, tongue powder, and Gatorade that was added to the buffer solution. For number 5, what are the systems in our body that acts as a buffer and how do they work? So there are systems in our body that acts as a buffer. The first is the carbonic acid bicarbonate buffer system, which serves as the ECF's dominant buffer due to its large concentration in the extracellular fluid or ECF. It's significant because the body has the ability to independently adjust the concentrations of the bicarbonate buffer's weak base and weak acid forms. As a result, the principal method for controlling the pH of the extracellular fluid is the modulation of the bicarbonate buffer. We can say that this is the most important buffer of the blood. Next is we have the phosphate buffer system that functions similarly to the bicarbonate buffer system. In every cell's internal environment, there is a buffer made up of hydrogen phosphate and dihydrogen phosphate ions. The hydrogen phosphate ions combine with excess hydrogen when it enters to the cell, which accepts it. In alkyne conditions, additional hydrogen ions that enter the cell are taken up by the dihydrogen phosphate ions. It is also important for buffering the renal tubular fluid and intracellular fluids. For the third one, we have the protein buffer system that functions as a buffer in cells and plasma. This interacts with other buffer system and aids in controlling the pH of both extracellular fluid and intracellular fluid. So number 6, what are the acids in our body and how to stabilize them in our body? So an acid is something that decomposes and contributes proton or hydrogen ions to a solution on a chemical level. So amino acids, fatty acids, ascorbic acid, and hydrochloric acids are the acids that are the most important to a human body. So alkaline water is one of the simplest things you can do to neutralize acid in your body. So your body can hydrate to the highest standard with alkaline water. You may help your body naturally remove extra acid from your system by drinking plenty of water. So for the last one, what is the pH of our blood and what will be the effect if it will increase or decrease than normal? So the pH of the human body ranges between 7.35 to 7.45. When the blood's pH falls below the 7.35, it becomes overly acidic and causes to what we call acidosis, means a condition in which there is too much acid in the body fluid, while blood that has a pH above 7.45 is too alkaline, which leads to alkylosis, which is there is too much base in the body fluids. So for the conclusion, let's have Miss ITURRALDE.
According to the experiment, the 3 buffer samples were tested with lemon juice serving as the acidic component and the baking soda serving as a basic component. For the first conclusion, the best buffer among them is the Gatorade. It has the reaction time since it was discussed that it has more basic components that are neutralized by the added acid, which is the lemon. The second conclusion is that all biological processes are dependent or pH dependent rather, especially the human body. In relation to the second conclusion, the blood's pH may vary both upward and downward. When the blood's pH falls below 7.35, it becomes overly acidic that can cause acidosis. Blood that has a pH above 7.45 is too alkaline, which leads to alkalosis.
For recommendation, prior to adding a precise amount of solvent, it is advisable to specify pH measurement. And for a second, before measuring pH, buffer solution should be allowed to warm to room temperature because pH is temperature dependent. Then third, in addition to the fact that temperature affects most buffered systems' pH, temperature is an important factor. Then last, the control of blood's nature is helped by buffer solutions. They have an essential role in the human anatomy. Since yung temperature has an impact sa pH, it is necessary to measure and account for actual temperature of pH buffers and samples while calibrating and measuring. This can be done by either letting the pH buffers and samples equilibrate at ambient temperature, or by putting them in a water bath that can be controlled in the temperature.
And that's our presentation. Thank you for listening.